Welcome to Introduction to Sample Preparation. The definition of sample preparation refers to essential steps taken to ensure high-quality XRD data by properly handling and processing crystalline materials. The importance of sample preparation is to ensure random orientation of crystallites, sufficient number of crystallites and sufficient diffraction intensity. There are two types of sample, well-ground sample and underground sample. For well-ground sample, the particle's size of at most 44 microns. While for underground sample, it can be able to distinguish individual grain not only by feel but sight as well. This table shows the contrast between well-ground sample and underground sample. A well-ground sample has a high signal-to-background ratio, ensuring clear peak detection. In contrast, an underground sample has a low signal-to-background ratio. In this section, we will discuss the effects of preferred orientation. Preferred orientation is the phenomenon that occurs when the crystallites in a powder or texture has a tendency to be oriented in one direction or set of directions. The effects of preferred orientation in samples are errors in phase identification, changes in skewing and peak intensities, distortion in intensity ratio, peak broadening or narrowing, and misinterpretation in data. There are a few methods that can be used to mitigate the effects of preferred orientation. The methods are by ensuring sample is well ground, use backfilling technique, avoid rubbing of powder sample surface, avoid excessive compaction, damping, mixing sample with filler and dispersion of thin powder layer using double-sided tape or Vaseline. Analyzing correct XRD patterns is essential for sample analysis. While process may vary with sample type, the overall process remains consistent. Three main sample preparation techniques are top-loading, backloading and side-loading. The correct setup ensures that the primary beam fully illuminates the sample surface without overspill, allowing for accurate data collection. Using wrong configurations, such as a divergent slit that overspills or an undersized beam mask, can compromise data quality. Following these guidelines, you can ensure that your XRD equipment is configured correctly, leading to precise and reproducible results. To obtain the HDPE sample, heat the HDPE gradually using a hot plate, furnace, or oil bath. Maintain a temperature between 120 and 160 degrees Celsius and avoid overheating, as it can degrade the material. Stir evenly to ensure uniform melting. To cast melted sample, prepare a clean mold, pour carefully to avoid air bubbles and cool at room temperature. Reduce internal stress and improve crystallinity. Next, carefully peel the solid HDPE off the surface if surface is uneven. Polish with fine sandpaper. Cut the sample to a size of about 1 by 1 cm and ensure uniform thickness. Avoid noise and overlapping peak in XRD analysis. Now, the sample is ready for XRD analysis.